Welcome back. In this session, we will look at and in a delete function by deletion of the last node of the single linked list. Let's assume we have the single linked list that first has the address of the first node. So according to the problem statement, I will have to delete the last node. So at the end of this routine, I should have this 25 node deleted, and I should have the next link of this node whose data field is 15 should no longer point to the last node, but this should become the new last node, right? So I should have deletion of the last node and a new last node. So if there are 5 nodes at the end of this routine, I should have 4 nodes existing in the list, right? So let's get to understand the first set of trivial cases, right? So let's assume the first case where the list doesn't exist, right? So it's obvious that when I see that the list doesn't exist, my first value is null, and hence I have nothing to do. So I could right away tell the user it's an empty list, I have nothing to delete. So you just have a printf statement telling the user nothing to do. It's an empty list. But if it's a case of one node existing, and that's obviously the node to be deleted, it's the last node. So what do? If this is the case, I should call free on this, deallocate it, and make my first back to null, signifying the fact that it's no longer having any nodes. So the code corresponding to it would be to say free first, give it back to the heap, the only node which exists, and I have to make sure first becomes null, right? So it doesn't automatically, first doesn't become automatically null when I call free of first, right? So it's not by default, so I will have to explicitly say let's make first equal to null, right? So this successfully deletes the only node existing, and that's the last node to be deleted. So case 1, case 2, let's see the case 3. Case 3 is the scenario where we have more nodes, more than one nodes existing in the linked list. As you can see, I will have to traverse the list to identify which is the last node, because I don't have a pointer which right away gives me the address of the last node, right? So I should have a while loop set up so that it jumps from every node, goes and stops in the last node, so that I know which is the node to be deleted. Perfect. But okay, let's assume temp is the variable for us, which will help us traverse the list. So I will have let me have 10 equal to first initially, and let me have 10 jump like this, and finally come stop here. Let me have 10 stop here. So what should be the while condition? Let's check. Let me put the while condition to be while 10 not equal to null. What would this do? This while loop, which within which there is a statement of progression, 10 is equal to 10 and next. Within this while loop, if I have this statement executed multiple times and it stops when 10 becomes null, I wouldn't have 10 stop here, but I would have 10 stop when it becomes null. This is not the case. This is not the case because I don't want my temp to become null. I want my temp to become or hold the address of the last node, right? So I want my temp to point to this node. So my while loop cannot be this. Let me change it. I will have to say stop at a node when temp's next is not equal to, right? Okay. So what would this ensure? I will stop at a node whose next is null. Let's assume I have done that successfully. I started from the first node, I kept going, jumping. I have come to the last one. Now I could right away say free temp, right? Which will get this node successfully deleted. But the other thing that we wanted to do was to make the next link of this last but one node as null. Correct? But do I have the address of that? No. Right? So I shouldn't move, or I should not have my temp go to the last node. But instead, if I had my temp stop at this last but one node, I could have said free on this last node, and I could easily make the next field of this node as null, right? So what we are trying to understand is, let's not stop our temp at the last node, but let's stop our temp node a step before, or in the last but one node. So what should I do? My while loop should still be updated now, so that I stop at the last but one node. And how do I do it? The logic to do it would be to not stop when temps next is null, but stop when temps next, arrow next is not equal to null. Okay? So what would this do? This will successfully make temp jump and come here, and this is the last but one node, right? So I have my temp stop here, and I understand that temp next, this is the last node, this is to be free, so I will say free temp arrow next, which is the node whose data field is 25, correct? So this will get deleted, and where is temp pointing to? Temp is still pointing to this node whose data field is 50, which is now the new last node of the list, right? So I should make sure temps next is null. So let me put that here in the code. I will say temp arrow next should be follow, right? So let's check it. What did I do? I started from the first node. I moved in the last but one node, right? And I deleted the last node, and the last but one node's next field is set to null, to mark or to signify the fact that this is the new last node of the linked list. So if I call display on this linked list, I will have 7 display, 10, 12, I come to 15, I display 15, and I stop for the fact that there's a null here, and this is the last node, new last node, right? So let's put all the three cases together in a routine which I would call delete last node. So this would be the entire code handling all the cases of no nodes existing, one node existing, and more than one node existing in the single linked list. And we're talking about deleting the last node. So this is my first case where I have first equal to null, where I say nothing to be deleted. The second case where there's only one node to be deleted. There's one node existing in the linked list, and that is the node to be deleted. I free temp, which is the first node, and I return null. Okay, I could say first equal to null and then return first, or just return null, because I understand there's a first value which is always returned, and in the calling function I would have written first equal to delete last node within brackets first, right? So I return null, which signifies the fact there was one node and that's deleted, and this is the else clause which handles more number of nodes existing, more than one nodes existing. It's the same logic. As I said, I have temp moving, stopping at the last but one node, freeing the last node. This is deleting the last node, right? And this is setting the next field of the last but one node as null, so that it becomes the new last node, right? So the return type of delete last node is struct node. I understand in case 3 there is no change happening to the first variable, but there is a change in the second case, right? So if you could see, I have the second case, the scenario of second case where one node exists, I have the variable first becoming null. So even if one of those cases you're altering your first, you have to make sure you return it or make it known to the calling function, right? And hence all these cases I say return. Okay, oh yeah, let's see return first here. So let me put it in the else clause as well. So I will say return first here, so that all cases the calling function knows if there's a change in the first, right? And this gets us to the end of understanding the logic of how do I delete the last node in any given single list. Thank you.